Hey everyone. So the worksheet 1 was assigned the other day. Today, worksheet 2 has been assigned. So what I think I'll do, and we didn't get through all of that one. We got through some of it. So I'll talk about worksheet 1. Then we actually had a quiz, a little half-sheet quiz that I'll talk to you about that when I get done explaining worksheet 1. Then I'll talk about what worksheet 2 was. We'll get through parts 1 and probably part 2, and then I might quit at that point. And then there'll be probably another video on the next day that goes through the rest of part 3 and hopefully have some conclusions then for part 3 of worksheet 2. So let me remind you, there are no notes. So those that aren't here, you wouldn't know necessarily any difference. But those that are here and have been here and just missed a day or something, we are not, I'm not standing up in front of the room and just giving you a bunch of things to write down. You are supposed to be getting that information as you work through the simulator, answering the questions along the way. Some of the questions have information that would be notes type of stuff, where you're learning about some terms and you're given some names of things that you need to know what those are now as they give them to you. So I hope you're kind of picking up on that. And again, I feel like using the simulator here, you're going to learn about atomic structure in a way that's just way better than me standing up in front and just telling you a bunch of things. So that's the route we're going. So first, let me get to there you go. Okay, so worksheet 1. Here we go. All right. So this is what you were supposed to have done first. This was, let's see, what is today? Today is Thursday. So this would have been Tuesday or Wednesday's assignment, depending on what block you're in. So you were supposed to manipulate each of the settings in the Build an Atom simulator, which again is this. So this simulator, you were supposed to look at all this and figure out what there is in here. And then, oh gosh, I hit the wrong thing. And then go through this, answering the questions. So name the 3 subatomic particles found in an atom. Well, what are those? And I had a lot of questions about, well, what does that even mean? Okay, sub means below. Sub means below. Atomic obviously means the atom. So below the atom. In other words, things that are smaller than an atom. Well, when you look at the atom builder here, do you see anything on the screen here that you think would be considered a subatomic particle? In other words, if this thing here is going to be the atom, these things right here are probably the 3 subatomic particles they're referring to. Since you've got buckets of these down here to put in here, that's probably what they're referring to. So yeah, protons, neutrons, electrons, those are the 3 subatomic particles. Now, I don't know if I mentioned this in the previous video or not, but I think I said something about, oh my gosh, what was his name? Copernicus. And it wasn't Copernicus, it was Democritus. It was another us. So Copernicus, he was dealing with the solar system and the planetary system. Democritus, a couple thousand years ago, he made a claim and said, hey, I think that all matter is made up of these tiny little indivisible, indestructible little lumps or clumps of matter. Now, indivisible. We had talked about that in class, about what that means. Indivisible. It's in the Pledge of Allegiance even. Indivisible. Unable to be divided. Right? Indivisible little particles. Now, we have since found out that they are not indeed indivisible. Like they can be split and they do fall apart. Atoms do. But the Greek word for indivisible is atomos, which is where our word atom came from. And so we've just used what Democritus claimed 2,000 years ago as our name for these small little pieces of matter. So again, proton, neutron, electron, and 3, you're supposed to practice dragging the different subatomic particles around in the atom. And so hopefully you did that. And it says which ones go in the center. And then it says in parentheses, bold, nucleus. So this is one of those situations where this is important information. Like nucleus, oh, that's the center of an atom. You need to know that now. So in the question, they're giving you information that are things that you need to know. So nucleus, the center of an atom. You need to know that now. And so which ones go in the center? Hopefully, you got in here and you were dragging things around and you saw that, hey, the proton goes in there, and then the neutron goes in there, and then the electron, it won't go in there. And try another one. The electron will not go in there. So apparently, only the protons and neutrons can go in the center, or what we call the nucleus. Okay, now which ones go on the rings around the nucleus? Well, we just saw that too. The electrons are the ones out here. So those are electrons in the rings. Now they tell you something else here, which is important. These rings represent energy levels. So these, the rings around the nucleus, are the electron energy levels. That's what they're called. You need to know that now. The electron energy levels are the rings. Again, instead of giving you notes on this stuff, it's all here in the packet. Then you are supposed to find 3 examples of different elements and fill in their information in the table, telling me what the number of subatomic particles in the nucleus was. You're supposed to sketch it, and then the name of the element, which again, you can see all that from here. So this first one I have right here, okay, this could be an example. I have a neutron and a proton. That's 2 subatomic particles in the nucleus. I have 2 electrons out in the ring, the first ring, and it's hydrogen. And so then I would just say those things. I have 2 subatomic nuclear particles. It is hydrogen, and I would sketch it. And I would sketch 2 little particles in the middle, and then 2 particles around the outside in the first ring, and then that would be it. That would be my atom. And you do that for 3 different ones. It doesn't matter what they are. It doesn't matter what you put in them. You just have to make one and then report what you did. So, should be easy. And it says you can build different atoms by altering the number of subatomic particles that you place in your atom model. Practice changing the 3 subatomic particles individually, which you just did to build your 3 atoms. And using what you know so far, determine what impact the changes listed below will make by filling in the table. So it says type of change and then what changes as a result. So if you add a proton, does the element change? If you add a proton, so if I add a proton, did the element change? Yes, it changed to a different element. It is now helium. It was hydrogen. So when I add a proton, does the element change? Yes. If so, how? The name changes. It's a completely different element. If I take away a neutron, okay, if I take away a neutron, I only had one in there. If I pull it out, is that changing the element? No, it's still helium. Okay, so no. Taking away a neutron? No, it does not change the element. Take away an electron. Oops. Take away an electron. Boom. It is still helium. It did not change the element. Okay, and then I believe the next one is if you add an electron, if I add an electron, I just added one, I put the one back, and then I added another one, and it's still helium. So apparently adding electrons, taking electrons away, taking away neutrons, or adding neutrons, I suppose, that wasn't on the list, that doesn't change the name either. But adding a proton changes it. And I add another one, boom, it's another element. And another one is a different element. So it's changing the element every time I put a proton in there. Okay, so now you're supposed to come up with, okay, what are the rules? Subatomic particle rules. Well, the protons and neutrons are only in the nucleus. The electrons are only in the outer rings, the energy levels. And it looks like the proton is the only one that can change the element. Those look like they would be rules that we could figure out by using the atom builder. Which leads us to question 6. Which of the 3 subatomic particles determines the type of element you have? Well, we just answered that. Which one of these elements, or of these particles here, which one determines the element that you have? Proton. The proton determines the element. Now, it was at this point that I gave a little half-sheet quiz, and the 3 things you have to be able to do for this quiz. So those of you that are gone and you'll be coming back, keep this in mind. You will have to take this quiz. This quiz is, number 1, do you know what the 3 subatomic particles are? Number 2, can you sketch me a diagram of an atom that has a nucleus with the particles in the right place and 1 electron energy level around it with electrons in it? Like, can you sketch that? An atom model, which again is what you were doing here. Just sketching the kind of thing that you were doing here. You don't even have to know what they are. You don't have to name them. You don't have to know which element it was that you built or drew. You just need to be able to put the right particles in the right place. And then lastly, you need to know which particle, which subatomic particle determines the identity of the element, which we just answered in number 6. Those are the 3 things you have to know for that first quiz, for this unit. Very simple. That's that. All right, next we had worksheet 2. So this would have been today is when I gave this. We finished talking about this. Everybody took the quiz. And now we have this worksheet. Actually, let me get into here. Let me get into here. So this, I can't make, dang. I can move that around. Okay. All right, so this is worksheet 2. Same thing, you'll click on the link. Now, again, I just gave this today, so you're seeing this video now, but you haven't done this part yet. I hadn't assigned this until today. So you need to stop the video if you're watching this without having done this yet. You need to stop the video and then do this worksheet. Worksheet 2, there's 3 parts. There's the charge part, then there is the mass part, and then there is the putting it all together part. 3. So you need to do this, then come back and watch the video, because right now I'm going to talk about what your answers should be, but you need to actually do this first. And again, you're using the atom build, or the Build an Atom simulator. So again, the link is right here in the worksheet. Get there and do this, and it tells you what to do. All right, I'm going to start talking about it. You should pause it and go back and do it if you haven't done it yet. All right, what in the simulation helped you decide if the atom is positive, negative, or 0 charge? Well, right here, net charge. That drop down tells you whether it's positive, negative, or 0. There it is. Hopefully you saw that. And what is the rule for making an atom with 0 charge? Well, hopefully you found out that to get 0 here, what has to be true? Well, right now it's not. I'm not 0 here. So let's see if I put that. Oh, look at that. So 4 pluses, 4 minuses. Now, the fact that those are red and those are blue, that should probably indicate to you that the red ones, the red ones here are the red ones here, which means the protons are what? Positive. Again, these are things that you would have probably written down in notes, but you're not doing that. You're actually discovering it here as you use the simulator. So these are things that need to be in here. Right? So I hope as you go through this, you're thinking about it and thinking about the things that you should be able to know now after having played around with this. simulator. So to get zero charge, you have to have apparently equal numbers 1, 2, 3, 4 protons and 1, 2, 3, 4 electrons. And again, you can see 4 here, 4 here. So the electrons and the proton balance is what gives you no charge, zero charge. Then the question becomes, okay, how do you have an atom that is positive charge? And not only that, notice it says a positive ion. Ion, that's another vocab type term. If we're talking about an ion, that is an atom that has charge. A charged atom is an ion. You need to now know that. There's no definite, you can write a definition down now if you want. It's telling you that a charged atom is an ion, and more specifically, it's telling you that a positively charged atom is a positive ion, and a negative charge on an atom is a negative ion. But anytime an atom is charged, it is called an ion. That's how you pronounce it, ion. So, how do you get a positive charge? Well, I just had one a second ago because I had more what than what? More protons than electrons, which gave me a plus charge. That means if I have more electrons than protons, okay, so now I have more electrons than protons, now I have a minus charge, negative charge. So hopefully you discovered that and found that out by looking at the simulator. Then you're supposed to build 3 different examples. And at this point, they want to know how many of each particle are in it. Then you sketch it. And you're supposed to, it says stable nucleus. You're supposed to make it a stable nucleus. Well, how are you supposed to know that? Well, hopefully over here, you looked at the bottom here and hopefully you saw, oh gosh, this stupid thing's in the way for me. And hopefully you were able to check this little box. Oh, that's not stable. Okay, so if I'm going to use this one as an example, I got to at least make it stable. Okay, there it's stable. So making it stable and so this would be an example of my negative charged ion. It's a -2. I have 6 electrons. I have 4 protons. I have 5 neutrons. That would be my little example. I would go here. In my comp book, I would write down I had 4 protons. I had 5 neutrons, and I had 6 electrons. I would sketch it, and then I would say that's a -2 charge. And then you're supposed to do that for a neutral one and for a positive one. Hopefully you did that. And the next part. So you're supposed to design a positive ion with a charge of +2. +2 charge. Now, for this one, what I did ask in class for this one is there an element that you cannot use for this? I'm going to do a reset and then recheck this thing. Is there one you cannot use to get a +2 charge? And so some folks, okay, that's stable. So can I make a +2 charge out of hydrogen? No. The most that can be is +1 because we only have 1 plus. And if I put another plus in there, what won't it be anymore? It won't be hydrogen anymore. And it's actually not stable. It doesn't tell me it's supposed to be stable, but I could make it stable, I suppose. How many can I put in there? Oh, too many. So that would be a +2. So this is the smallest atom that I could make, the smallest one I could build. They would have a +2 charge. Now, if you made lithium, hopefully, if you did this, then you had to do what? You had to put 1 electron in to get a +2. If you made beryllium, then you would have to put another electron in to get a +2. And if you made boron, you would have to put another electron in to get +2. So again, I don't care which ones you built, but you're supposed to build one that has a +2 charge. And hopefully you're seeing that it has to have 2 fewer electrons than protons to have a +2 charge. And then you're supposed to answer, okay, is it stable or unstable? Now, number 6, how many total electrons can fit into the first ring around the nucleus? Hopefully you found that out, and it's only 2. If I try to put a third one in there, it will not go. I cannot put a third one. I cannot put a third one anywhere in the second ring. It will kick it out to the next ring. Now, hopefully you then also find out that all the rest of these, the 8 that are left, fit in the second ring. Now, the answer to this question then, is it 8? How many total electrons can fit into the second energy level? Is it 8 because that's how many can fit in it? Or is it 8 because they only gave us 8 more? Well, it's 8 because that's all it can fit. The first level holds 2. The second level holds 8. All right, for a total of 10 in the first 2 levels. You need to know that now. So again, the answers to these questions, you need to know that the first level can only hold 2 and the second level can hold 8 for a total of 10 in the first 2 levels, maximum. So now you need to know that. And moving on. So now we're at the mass part. We just barely got into this. I'm going to go ahead and finish, I guess, part 2, because part 2 is just this one thing here. So it says, which subatomic particles are heavy, which ones are light? I hate the way they ask this question, but it is what it is. And then it says to rank the mass of each of the particles. So we'll go back to the simulator and we'll just start playing around. So I see mass number here. So let me drop that box down. It says we have 7 right now. Well, what do you think that is? If I do this, it went up 1. If I do this, it went up another 1. If I do this, it went up another 1. I keep putting neutrons in, it keeps going up 1 every time. And if I change the element and add a 6th, okay, so now it's carbon, and it went up again by 1. Another proton, make it nitrogen, now it's 12. Another proton, 13. Another proton, slipped, 14. So apparently, every time I put in another neutron, 15, another neutron, 16. It goes up 1 every time I put another proton or neutron in. All right, how about electrons? Another one, no change. 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 So electrons aren't changing it at all. Protons and neutrons both have a mass of 1. Electrons have a mass of. Now, do they really have a mass of 0? Well, not technically. They're almost 2,000 times less massive than a proton or a neutron. So it's almost like there's no mass. 2,000 times less. That'd be like going to the doctor's office and having a handful of paper clips in your pocket, and you're like, whoa, I better take this out. When I step on the scale, because they always weigh you when you go into the doctor's office, they always weigh you. And so that'd be like you saying, hold on, let me get my chapstick out. I'll put that down. Okay, now you can find my weight. That's kind of how an electron is. You don't even notice it. They're not gonna look at your chart and be like, whoa, looks like you lost some weight. Or maybe you forgot to take it out, or you have your wallet in your pocket. One time you're at the doctor's office, you don't have it in your pocket the next time you're at the doctor's office, or your keys or your phone or something. And they're like, wow, I think maybe he's putting on some weight, or, oh my gosh, I think he's lost some weight. So that's not, the electron is so small in mass, it's not part of what we call atomic mass. So then question A here, what is the rule for determining the mass of an atom? Well, the mass of an atom, it looks like, if we look at the simulator here, 16. Where do we get 16? Well, I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That looks like the total number of protons plus neutrons is my mass. That's my mass. And again, you'd have to have 2,000 electrons to get 1 for a mass. You can't fit 2,000 electrons in an atom. So that doesn't work. Now you're supposed to design a neutral atom with a mass of 5. Neutral atom with a mass of 5. Now, you got a lot of options here. Well, I shouldn't say a lot. You have a few options. But it has to have a mass of 5 and it has to be neutral. So now it doesn't say whether it has to be stable or not. It just says neutral with a mass of 5. So let me reset this again. I am going to click the stable versus unstable just so I can see it. And I'm going to get those drop down. Okay, so a mass of 5. So one of those, and then if I put 4 of these in here, is my mass 5. Sure enough, it is. And it's supposed to be neutral. It's not, so I got to put one of these in here. Okay, that's a neutral atom with a mass of 5. So that satisfies what I was asked to do. A neutral atom, mass of 5. I had 1 proton, I had 4 neutrons, and I had 1 electron. Now, name of the element, for me it was hydrogen. Mass, 1 proton plus 4 neutrons equals mass of 5. Is the nucleus stable or unstable? Well, for mine, unstable. Okay, so I write that down. That's all you have to do. And again, you have several options. If you do helium, then you have to take out what? A neutron. To still have a mass of 5, you have to take 1 neutron out if you're going to put 1 proton in. Now it's helium, but I'm not neutral anymore either. So now I have to adjust my my electron number. Okay, so now I've made it neutral, and it has a mass of 5. That's how this works. Okay. Now, the biggest element you could have with a mass of 5 would be what? Let's see, lithium, I got beryllium, I've got boron. Okay, now I've got 5. I can't put any neutrons in here if I use boron as my example because I'm already maxed out at a mass of 5. I'm also not neutral. I got to fix that. So hopefully you were able to do that. And again, the conclusion here for the mass part is that protons and neutrons together determine the mass of an atom, not the electron. We got that? Now, the next video we'll finish. I'll get to the putting it all together thing, and we'll go through this little table here, and then we'll talk about the element symbol, all that stuff. So we'll get to that next time. I know this video is long enough. Sorry. But hopefully you are learning, even at home, you're able to use the simulator and learn what you need to learn about how an atom structure is. I'm sure some of this you've learned before. So hopefully this is either reminding you of things you have forgotten in the past, or maybe you are learning some new things, and that's good. But remember, there are no notes here. This is your notes. So you have to be paying attention to, like, for instance, what is the rule for determining the mass of an atom? Hopefully you wrote down protons plus neutrons is mass. Like that would be something that would be in your notes if we were taking notes traditionally. But right now you're doing this, kind of discovering this on your own using the simulator. So all those things are important that you're writing down in your comp book. And that's why I want this in your comp book and not on a separate sheet, so that it is there in your comp book, and that's like your notes now. So anyway, I'm finally done talking. I need to quit talking. So have yourselves a great weekend. We'll pick this back up next week with a new video, going through part 3, and then doing what's next, which will be eventually another quiz after we have some conversation about the rest of this worksheet. That will lead us to another quiz. So I think that's it. I think I'm done. Take care of yourselves. We'll see you next time.